So in this style of problem, you're going to be asked to find the Ksp, but you'll know the amount that is able to dissolve in the solution. So we know the solubility. Sometimes it's provided in grams per liter, sometimes it's provided in moles per liter. So you have to just be aware that you might have to be converting it to molarity before we can plug it into our value, into our equation. Let's consider this equation, where we have 2 grams of copper 2 hydroxide dissolved in 100 milliliters of solution, and we're trying to find the Ksp. So just like our previous problem, you always are going to start out by writing the dissolution equation. So you're going to have copper hydroxide solid dissolving into copper ions and hydroxide ions. And you want to make sure that you balance it, so we would have a 2 for the hydroxide ions. So that's our dissolution equation. The second thing is that we also want to write our Ksp. So Ksp, we know, is equal to the concentration of the copper multiplied by the concentration of the hydroxide raised to the coefficient 2. Now, the next thing we want to do is find the molarity of the copper hydroxide that is dissolved. So molarity is moles per liter, but we're only provided with grams and milliliters. So we're going to have to do a couple of conversions here. So I'm going to start out with my 2 grams and my 100 milliliters. We know that the molar mass of copper hydroxide is 97.5 grams for every 1 mole. So that cancels grams. And we know that this one's easy, 1,000 milliliters is equivalent to 1 liter. So that will get rid of our milliliters. So once we're done with this calculation, we're going to have moles per liter. That's our molarity. So on the calculator, this comes out to 0.205 molarity. Now, we know that that is equal to the molarity of the amount of the copper hydroxide that dissolves. Now, the amount of copper hydroxide and the amount of copper ions, those are in a 1-to-1 ratio because there's 1 copper ion for every 1 copper hydroxide. But for the hydroxide ion, the molarity is different because there are 2 hydroxide ions in the equation when it dissolves, and so we're going to need to account for that fact. We know that the molarity of the hydroxide is double the molarity of the copper, so we can just multiply this value by 2 to get the molarity of the hydroxide ion. So now that we know both of those values, we can plug it into our Ksp expression. Ksp is going to be equal to the concentration of the copper, 0.205, times the concentration of the hydroxide, 0.410, raised to its coefficient, so it's squared. And when I do this on my calculator, it comes out to 3.3 times 10 to the negative 2. And that's our final answer.